this lesson, we're going to be talking about direct and inverse variation. And you can see here that I have my Desmos calculator up because I'm going to show you how to graph these inverse and direct variation equations. The first thing we're going to talk about is direct variation. And this is a linear equation of the form y equals kx. The variable k is called the constant of variation, which is also better known as the slope. And these types of equations, these direct variations, are always going to pass through the origin. That's what makes them very unique. So let's go ahead and look at this first example. It says here, graph the equation y equals 3x. So knowing what we know about this equation, we know that the 3 is the constant of variation. That's the slope of the line. So really, we already know how to graph this by using our slope and y-intercept. But I do want to show you another method using the graphing calculator on how to actually figure this out. So what we could do is go over to Desmos and type in our equation, y is equal to 3x. And you can see that it graphs it very nicely on our calculator. But if we want to know what those individual points are on that line, we can go up to this little gear up here, and then we can click on the table. And it'll convert this into a table, and it'll give us all of those coordinates that are on this coordinate plane. And if there's something there that if there's something not there that we want, we could go ahead and add it. We could add another coordinate and it'll give us that number. So let's go ahead and plot those coordinates. And I always like to stay on the coordinate plane that's given. So I see that I have -2, -6. So I'm going to go ahead and back over here on my notes, I'm going to go ahead and plot that. Let me go ahead and bring that over here. There we go. So -2, -6 is going to be about right there. -1, -3 is going to be about right there. 0, 0, there's our origin. 1, 3, and 2, 6. And that will go ahead and be all of those points that are on that line. So you can see that we can go ahead and draw a nice line through there with arrows at the end. But this represents a direct variation equation. So kind of going backwards now, we can look at this next example and let's go ahead and figure out what the equation is. We know that it's going to be in the form y equals kx. So let's start with y equals. Let's figure out what our slope is. It looks like our slope is a rise of 3 and a run of 2. So it's going to be 3 over 2 times x. And it's passing through that origin, so it's going to be plus 0. So we're just going to leave it the way that it is. And you can see that our constant of variation is 3 over 2. And that's the general idea behind a direct variation. Now let's go ahead and look at an inverse variation. Okay, inverse variations are a little bit different. They're going to have a different look to them because they're a linear equation of the form y equals k over x. Where the variable k is still the constant of variation, but it's just going to look different. The direct variations are linear. They're creating a line. But inverse variations are going to create a graph that you see here over on the right. And that's what a graph of an inverse variation looks like. So let's go ahead and graph this one that we see here. Y equals -4 over x. So I'm going to go ahead and type that in. Y equals -4 divided by x. And you can see that, notice how my graph is in quadrant 2 and 4. And the reason that is because our constant of variation here is a negative number. Where over on the right, you can see that they're in quadrants 1 and 3. That's going to actually yield a positive constant of variation. So having that said, let's go ahead and look at the table of values. I'm going to go ahead and press edit. And I'm going to look at my table of values. And again, I might have quite a few points, I might not, but you can see here that here are the ones that are given to me. So I'm going to go ahead and graph it. -2, 2. There we go. And -1, 4. There it is. And what else do I have here? I notice how it says 0 undefined because it's not passing through that origin at all. I have 1, -4, and I have 2, -2. There we go. And just to kind of continue this pattern, I'm going to go ahead and check to see what x, when x is -4, what that's going to give me. And you can see that I kind of continued it on my line over here. I'm going to go ahead and plot that as well. There we go. And I'm also going to go ahead and figure out when x is +4, I see that my y is -1. So once you generate enough of the line where you can graph it, you can go ahead and finish it with a nice curve with arrows at the end. There we go. Creating your inverse variation function. All right. Determining an inverse variation graph and determining its equation is a little bit trickier than what we've been doing, but let me show you how to do this. So we have to kind of think about our direct variation equation. I'm going to go ahead and maximize my screen here so you guys can see. All right. So notice our equation is y equals k over x. And sometimes you'll actually see y equals k over x written like this. We actually simplify and we multiply both sides by x to get k by itself, because that would tell us what our constant of variation is. So the reason we would do that is to now determine what is the k in this case. So I'm just going to go ahead and pick a coordinate that is a nice cross-section coordinate. What I mean by that is like right here. You see how that coordinate is right at a cross-section? That's how I'm going to determine what my constant of variation is. That x value you can see is 2, and my y value there is 6. So if I were to use this formula here and say, okay, well, 2 times 6, that's going to give me a constant of variation that is 12. Let me show you that again with a different point. What if I chose this point down here? That point there has an x value of 6 and a y value of 2. So again, using that formula k equals xy, I could solve that and say, okay, well, 6 times 2 gives me 12. And so the purpose of doing that is to show you that this could create the equation y equals 12 over x. And this is the equation of this inverse variation. Okay, now that we've looked at the actual graphs of a direct and an inverse variation, let's go ahead and look at some relations. Remember we talked about relations in Unit 3? It says here, determine if the relation is a direct or inverse variation. Then determine the constant of variation k. So what we want to do here is to keep in mind the formulas. Remember, a direct variation is going to be y equals kx, and an inverse variation is going to be y equals k over x. And here's how we're going to determine this. You can start with either formula, whichever you feel is easier for you. Usually people gravitate towards the direct variation. So let's just go ahead and use that direct variation formula. And let's look at our table, or I'm sorry, our set of ordered pair here. Let's go ahead and see if we can manipulate this formula around here. I'm going to go ahead and take the formula y equals kx, and I'm going to solve for k. Watch what I'm going to do. I'm going to divide both sides by x. That's going to give me that k is equal to y over x. Now keep this in mind, because now we're going to go up to these ordered pair and see that if we divide y divided by x, we should get the same k value if it's a direct variation. So let's look at the first one. Y divided by x. Well, that would be 4 divided by 1 would give us a k of 4. Okay. What about the second one? Y divided by x would be 8 divided by 2, which is 4. All right. Y divided by x, this one would also give us a 4. And of course, this last one would also give us a 4. If they all give you the same constant of variation using a particular formula, which we use the direct variation, then that means that this is a direct variation and the constant of variation is 4. Now, let's go ahead and do the same thing for the table of values and see if that's what we get. I'm going to use my k from my direct variation, and I'm going to do the same thing over on the right-hand side. I'm going to say, okay, well, y divided by x, so that's negative 12 divided by negative 0.5, okay? Now, that's going to give me a k is equal to 24. Let's try the next one. Negative 6 divided by negative 1. That's going to give me a k of 6. Do you see how they're different? That means that this cannot be a direct variation. It has to be either an inverse variation or neither. So let's go ahead and test the inverse variation formula. Here's my inverse variation formula. Y equals k over x. I want to solve for k, so I'm going to go ahead and multiply both sides by x to get k is equal to x, y. I'm going to use this formula up in the table now. So let's go ahead and multiply x times y to get k. So x times y in this first example is going to give us 6. So k is equal to 6. In the second example, you can see it's going to also give us 6. It's also going to give us 6 here, and it's also going to give us 6 here. So because the constant of variation is the same, and we use the inverse variation formula to make sure that the k values were all the same, this is an inverse variation, and our constant of variation is 6. So that's how you figure that out given a set of ordered pair or a table of values. Okay, let's try something else now. Determine the constant of variation k, and then determine the missing information. Look at this first example. Y varies directly with x. So we know that this is going to be a direct variation because y varies directly with x. So right off the bat, we can go ahead and write down our formula. Y is equal to k times x. That's direct variation. Now look at the information they give us here. If y equals 10 when x equals negative 4, find y when x equals 12. Now you could set up a proportion here, but we also need to figure out the constant of variation, which you can't figure that out using a proportion. So let me show you what to do here. Let's go ahead and start with the first piece of information. When y is equal to 10, we don't know what k is, but we do know what x is. We know that it's negative 4. So let's go ahead and solve for k. I'm going to divide both sides by negative 4. And my k is going to equal negative 5 over 2. That is my constant of variation. Now, I'm going to use my constant of variation to find y when x is 12. So, when we're looking for y, we know that the constant of variation is negative 5 over 2, and we know that x is 12. You see what I'm doing here? I'm just trying to find the missing information. So if we multiply those two by each other, that will give me a y value of negative 30. So it says find y when x is 12. Well, when x is 12, y is negative 30. And that's using our direct variation formula. Now let's look at the same type of problem with an inverse. It says y varies inversely with x. When you see that, go ahead and write down your formula. Y equals k over x. That's our formula. If y equals negative 8 when x is equal to negative 3, find x when y equals 4. And make sure you figure out that constant of variation as well. So let's start off by saying, okay, well, negative 8 is equal to k over negative 3. Remember, we're trying to find k first. So I'm going to multiply both sides by negative 3. So 24 is equal to k. We'll go ahead and rewrite that like this. This is my constant of variation. Now, substitute that in to find x when y is 4. So y is 4. My constant of variation is 24. And I'm looking for x. So you could probably do this in your head, but let me show you how to algebraically solve this. I'm going to multiply both sides by x using my literal equation skills. 4x is equal to 24. And then I'm going to divide both sides by 4 to get x is equal to 6. So we were searching for x and we found x. So you always have to go and pass through your constant of variation to determine what that is, and then apply that constant of variation into the equation to determine your missing value. Okay, I have 2 more problems for you, and these are word problems. So these are word problems using inverse and direct variation. Let's look at this first one. The gallons of water used to take a shower vary directly with the number of minutes in the shower. If an 8-minute shower uses 48 gallons of water, find the constant of variation and then determine the number of minutes spent in the shower if 30 gallons of water were used. So the first thing we know in this problem is that this is a direct variation problem. So we're going to be using the formula y equals kx. It's very important to use the right formula. Now, since we're talking about an application problem, we actually have variables that mean different things. So in our case here, x is going to represent minutes, and y is going to represent gallons, so gallons of water. And let's go ahead and use the information in the problem. It says here, if an 8-minute shower uses 48 gallons of water. Let's stop there. Using that information, we can determine what our constant of variation is. So we have 48 gallons of water equal to k times 8 minutes. Let's go ahead and solve for my constant of variation. My constant of variation here is going to be 6, and that's important. Now we're going to take that piece of information and apply it to the last piece. It says here, after you find the constant of variation, we're going to determine the number of minutes spent in the shower if 30 gallons of water were used. Well, remember, y is our gallons, so 30 equals my k, which we now know is 6, and we're looking for the number of minutes spent in the shower, which is going to be our x, which is what we're trying to figure out. So now we can divide both sides by 6 and get that x is equal to 5. And in our case, this is going to represent 5 minutes. So you can use your formula for direct variation to figure out problems like this. Okay, the last problem for today is an inverse variation. The cost per person to rent a cottage varies inversely with the number of people who share the rent. If 7 people share and it costs $42 per person, find the constant of variation and then determine the number of people renting the cottage if the price per person is $98. Let's start this one by recognizing that this is an inverse variation. So this is going to be y equals k over x. Okay, let's represent our x and y. Let's define our variables. X is going to represent the number of people. And y is going to represent, we'll say, the cost per person. Oh, we'll just say the cost. Okay, now that we have everything defined, let's go ahead and find the information that they give us. If 7 people share and it costs $42 per person, that's the given. Let's plug that in. So we have $42 equals k over 7. Okay, and let's go ahead and simplify this out. So 7 times 42 is going to give us a k value of 294. That's our constant of variation. Now let's go ahead and apply it. So after we find that constant of variation, determine the number of people renting the cottage if the price per person is $98. So $98, that's our y, is equal to 294 divided by x, because we're looking for how many people. So let's go ahead and solve for x. I'm going to multiply both sides by x. 98x is equal to 294. I'm going to go ahead and divide both sides by 98. And I'm going to get, let's see here, x is equal to 3. So 3 people would bring that cost to $98. And I can really plug in any number there. If it just depends on, you know, if I want to figure out how much it's going to cost for 4 people or 5 people or 6 people, I can plug in any number into that formula and it'll work. All right, that brings us to the end of our lesson on direct and inverse variation.